All right, let's go ahead and take a look at this 2023 number 4, a very low scoring free response question. So let's take a look at it. So this is the one where we are wondering on the average difference. So if we take a look at the information it gave us enough information to do two separate independent means or a matched pairs problem. But what happens is, if you read this section here, you can see that in week 1, the subjects were randomly assigned to take either the placebo or the omega-3, and then they waited, and then in week 3, they got the other treatment. That means that was crossover design. So each subject was its own matched pair. And so therefore, we're interested in the average difference between how on average, how did they do, difference between the two different treatments, or which placebo and the omega-3. All right, so therefore, the information I want to use is not two separate information pieces of data. I don't want to know that or this. What I want is the difference, and then I'll be using this picture here. All right, so then let's see how this looked. So we came over here and I used this to help me in the parameter I defined. So I also looked at how they did this problem. They actually told me they wanted me to do placebo minus omega-3. If you did it the other way intuitively, that's fine. Just as long as, technically in that case, this would have been a negative number. So that plays into what you would have gotten if you did it in the calculator, or if you did the problem by hand. It kind of would have switched that around. But overall, so I just kept what they did, but it did make the hypothesis statements in the sign tricky here. So we'll talk about that in a second. Anyway, so first I recognize this as matched pairs because the subjects did both treatments. Okay, so then I want to do everything in terms of just one mean. So here I have the average difference, okay? The average difference in the things. So let's see here, average difference in irritability score of all patients with the medical condition similar to the volunteers. And you could say in the study or whatever, but that's probably just an okay assumption there. All right, so average difference in irritability score of all patients with this medical condition like the volunteers. The null hypothesis, of course, is that that average difference was 0. And by the way, notice that I defined that way as, and I probably should have written it here, placebo minus omega-3. But I think because I used letters that make sense, I would have been okay. I think I was okay on as long as I defined the subtraction somehow. Okay, so of course, null hypothesis, that there's no difference. And the alternative hypothesis, here's a trick. So this is tricky because a lot of people want to say, because they go back up here and they go, oh, I want to see if the treatment decreases the average irritability score. So if you had put omega-3 first minus the placebo, then you would see if the omega-3 is less than the placebo. So that difference would have been 0, okay? But that's not the way they guided you to do the subtraction. Okay, so the way they guided you, and I'm telling you, I know they did this on purpose to check and see if you really understood what you were paying attention to, the direction of, and what the average was indicating. If you're doing placebo minus the omega-3, then that means the placebo, the one that's coming first, is greater irritability than the omega-3, okay? Because we want to see if the omega-3 decreased it. In other words, the placebo is greater. So that's why this is a greater than sign here and not a less than sign. Tricky, tricky, tricky. All right? Okay, so next, then I did the assumptions. So These were volunteers, so they obviously were not randomly selected. And this is an experiment. So we're looking for random assignment. So here we had subjects, and it was stated that they were randomly assigned to which treatment they took first. And so that's what I had to indicate here. Oh, I should have put 19 subjects, okay? And then so then here's the other thing that sometimes doesn't make sense. Okay, so for independent, if I say 19 is less than 10% of all people, okay, what? That doesn't really make sense. I'm like, 19 is less than 10% of what? All people on this, with this problem, this medical problem? 19 is, that doesn't really make sense because we just have an infinite amount of subjects to select from. And so that actually doesn't make sense either there, sampling without replacement. I mean, when we have an infinite amount of things to come from, it doesn't really matter. So we technically do not do that 10% condition when we are assigning to an experiment and have that infinite amount of subjects. Okay. So no, large enough? It is not large enough. 19 is not large enough. So the box plot, we need a picture, okay? And they gave us a picture, but it was not a dot plot. They gave us this box plot of the differences. So do make sure you say the box plot of the differences, so they know you're talking about that one and not this here. So this box plot of the differences is somewhat symmetric, and the modes I don't know. So because you can't tell modes from a dot plot, it could look like this. That's somewhat symmetric. You don't know. So you leave that off, okay, because you can't tell. So somewhat symmetric. If I could tell, I would say it's unimodal, but I can see that there are no outliers. So I was only able to do the S and the N, and so that's why I just put that. And then don't forget, approximately normal model applies. All right, this is a one mean t-test for matched pairs. Now, if you did this by hand, it would look like this. Here's your t-score, which you didn't have. Where's my little cursor? Okay, I can't find it, but here's my t-score. There's the formula that we're using to get that t-score. But here is it filled in. See, they gave you this information, the average of the sample differences and the standard deviation of those sample differences. So, and then that null hypothesis was zero difference. So here's what's happening. For the differences of the placebo minus the omega-3, they should, on average, they should be centered at 0. But I got this sample difference up here of 1.789. That gives me a t-score of 3.14. So at this point, I'm already having a little suspicion. But I can't make a claim with a test statistic, the t-score. I have to have that p-value. So that p-value, I get that TCDF with 18 degrees of freedom, and there that gives me that. So my p-value, of course, being 0.0028. Make sure somewhere in here you have written and acknowledged a degrees of freedom of 18, or you have lost some credit there. Now, you might have chose to just do this calculator. If you came and you did the calculator, you went and put it in like this. And if you put it in like that, then what you have to know, oh, I didn't put the answer there. What it gives you is it comes up, and the first thing it says is t equals 3.14. The p-value is the next thing under it, and that's 0.0028, and then degrees of freedom. So minimally speaking, what has to be included, if you did it in your calculator, is this, and of course also degrees of freedom. So you have an option there. Do you want to do that by hand or put that in the calculator? All right, our p-value is low, so we reject HO. Since the p-value is less than alpha, I reject HO. There is enough evidence to go with HA. So we have enough evidence to indicate, don't say prove here, anything like that. We have enough evidence, our evidence suggests, we have enough evidence to suggest that the average difference, remember with matched pairs, that's our magic words, the average difference in irritability score decreases with omega-3 treatment. Or you could say the average difference in irritability score is higher with the placebo. But typically we want to answer the question it asked, which was about does the treatment decrease the irritability score on average? Okay? You have to have, it's on average. It's the average difference that gets decreased. Okay? All right. So there's that one. And so there should be an extension to this, and that will be a panic model that I make so that you could see how that would go. Okay, so you could see if I was estimating what that difference is. Okay, so there you go on your 2023 number 4.